So I just moved everything to modular hardware. The nut holes are here. Here are the square nut holes are a little bit thick because I didn't realize it, but when I ordered the square nuts, they are 2.4 millimeters thick instead of 1.8 millimeters thick. I moved everything over from here, so there's a few different things that are nice about this version over this version. This version, I pretty much had to print, let's see, what orientation did I print this in? I think I printed it like this. And the reason for that is because, well, there wasn't really a good orientation, but that was the orientation that I went with. This, I can print the parts in different orientations, so like this prints like that, and then this prints the way that it's oriented right now. I just put everything together. Oh, I also realized when I did all of that the this hole, the window to the numbers on the shaft, or the window to the numbers on the dial, was a little bit lower. So the whole thing was set up assuming that the dial was like a full millimeter down from where it actually is. So now the alignment between the shaft on this motor and the dial is better. Another consequence, or another cool thing that this setup has, is there's a little notch right there that indicates what number is the current number. So like right now it looks like it's about 15. This is what it looks like when it runs. I'll press the reset button. Oh, I gotta turn on the motor power supply. Okay, so it runs. Oh yeah, I'm not really sure what to make of that. So sometimes when it's running, it gets into a state where it thinks that it has it can use the encoder to see if it's actually gone as far as many steps as it has tried to go. And right now it's in a state where it keeps resetting. So it notices that there's a difference between what the encoder says and what the stepper says the position should be. And so I reset and I go with what the encoder says, and then the code should continue smoothly from there. And sometimes it does and sometimes it doesn't. I don't know what the deal is. Oh wow, it's getting loud. Anyway, it'll run through, and then after it's done inputting, it will move the dial arm up and down. And another thing that isn't working at the moment is when it moves the dial arm up and down right now, it just declares that it worked. It doesn't actually know, it doesn't actually tell whether it worked. It just, every time it declares that it worked. So I'm guessing that the feedback is just always giving a value that's super high or low or something. And it is kind of wrapped among the other wires, so maybe there's interference there. And the output looks like that when it's having that error that I was talking about where the stepper and the encoder disagree. So this is where it's saying what the stepper says and what the encoder says, and then it's resetting, but then you can see that it keeps on going into that same spot, and so it gets that click, 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 because it takes a moment to reset itself, and then it tries again, and then it immediately thinks that there's a problem. Let's see, I think that's all the different stuff that's in play right now. So I plan on fixing it so that it can tell. I'm going to spend a little bit of time making it so it can tell where the servo arm is. I need to... Oh, another thing that would be nice to do, which I'll try to do next, is when I initially turn it on, it's kind of hard to get it to stay at a specific location. So what I'll do is I'll have at the very beginning, you have to say what number it's at, and then it will try to go to 0, and then it'll keep asking you until you say that it's at 0, and then it'll start doing the whole process. I could try to be fancy and like whatever number it's at when it starts, just start off the stuff from there, but whatever. So yeah, that's the current state of things.